Okay, I'm in a common ordinary Walmart. To answer a couple of questions that were posted in the comment section on a video I did about an inverter. There was a guy that was talking about how modern electronics, whether or not they work with a sine wave or non-sine wave, what they call modified sine wave inverters, which is really common. And the other question is, of course, we need to understand that a lot of modern electronics that run, let's say, on USB power, and then have all these little adapters like you might see with different USBs or cell phones or Samsung phones, all of those laptops at the beginning, all the charger type stuff for these game systems. A lot of these things are going to involve a lot of these, but not all of these, but a lot of them are going to involve a power adapter as part of what's happening with that particular device. It's usually we call them a wall wart, where it's on the power cord. Now, what you can get for a lot of these things, though, is like one of these multi-DC power adapters, and there's a couple of ways these things work. Like this one right here works for low-powered electronics, and it has USB power, and it plugs into a cigarette lighter plug. So what you want to do is try to make as few conversions from AC to DC or DC to AC, then back to DC. Look at the little power adapter, like these things. We call these a wall wart. You look at the power adapter, look at the type of plug that's on it, and then take a look at how many watts, volts, amps it is, and usually that's going to be on a label. One of the things that we're finding with a lot of electronics from the 90s up to the early 2000s is a lot of that stuff ran on 12 volt anyway. It's 12 volt stuff. It's manufactured as 12 volt stuff, and then depending on what country you're in, it depends on which chargers you get, whether they have the American style plugs or let's say the European or Australian style plugs. So like here's a wall charger, and of course they want you to turn it over, try it, and make sure that the plugs are compatible, and a lot of them have different plug setups. When you're trying to get your electronics to work off-grid, what you need to do is you need to match two things. One is matching your voltage. The other is matching the plug tip style. Now, the other thing, it's a number 3 thing sometimes you got to match, is the polarity on those little plug tips. If it's something that's made in America for the U.S. market or made in China for the U.S. market, the way these usually work is the outer portion of that, it's an inner outer, okay? It's not a left-right when you're talking about DC stuff. It's an inner outer. The outer is usually the negative, the inner is a positive. So if you ever need to check it with a little voltage tester or something, that's how you do it. Now this device is similar to something that's been on the market for a long time, and what this is a car cord adapter with USB power, which means it has USB power on there. And then if you look, there's a little selector here where it goes anywhere from 12 volt down. It's easier to reduce voltage than it is to increase it. We can see that increased on the car chargers for a lot of power tools and for laptops. That's because a lot of power tools and laptops are running anywhere from 19 to 22, 23 volts when they are charging, okay? So this one is for 12 volt and below, and then it comes with a bunch of tips for various items. This is one of the ways that you can get a lot of items to work without having to go and plug something like this into an inverter, because what these things are all doing is they're taking AC power and making it DC power with one of these funny plugs. So what you really want to do when you're dealing with anything that's DC, that's off-grid, that's solar, you want to keep it native DC whenever possible. That runs into things with DVD players, a lot of electronic devices, clocks, clock radios, pretty much anything that has its own little internal battery that runs the device probably actually runs on DC power. And then some of these adapters are a little different from others depending on the plugs. Again, at a local Walmart, something we're looking at the backs of these TVs. These TVs all run on AC power, okay? They all run on AC power, and the way we can determine that is that the plug has no modification by the time we get into where it plugs in. Now, I deal with these pretty regularly because I do do in-home installations on them. That little DVD player, I looked at its plug. These vary, okay? Some of them are native AC, and that's that. Other ones, especially if they were intended for a world market, will have that little power adapter. And what that actually does is it converts things over to DC. And again, a indicator that a device probably actually runs on DC is that it has an internal battery of some sort that actually runs the device. And when you plug it in, what you're actually doing is recharging that internal battery. For example, with a laptop, portable DVD player, any sort of a smartphone, a lot of other devices of that nature. Now, when we talk about kitchen appliances, anything that has a spinning motor and no internal battery, then those devices do run an AC only. And if you buy those in a DC variant, they tend to be lower capacity, more expensive, and quite often lower quality. And yeah, those devices can burn out a little bit more quickly when you're running the AC versions only. Well, here's where you make an adult decision about your equipment, okay? If you are running AC devices through an inverter, as opposed to getting DC devices of the similar type, like on these flat screen TVs, they're not major bank-breakingly expensive for a decent-sized flat-screen TV. If you, 198 bucks for, I think that's maybe a 32-inch. Yeah, 198 bucks for a 32-inch. You can buy those in the DC world. You can buy those things. They're usually engineered to work with boat and RVs. The thing is, they'll be 3 times the money. And so when it's 3 times the money to get one that runs on native DC, then you're going to have to make an adult decision on whether or not you think that it's worth buying your TVs more frequently. And for me, and the other thing I'm finding is that so-called pure sine wave inverters don't seem to help the situation much. And they're a lot more expensive. So what I'm finding is I'm better off taking every device that possibly runs on DC, that possibly runs on an internal rechargeable battery, and I just get the adapters, the cigarette lighter adapters, the 12-volt adapters, and make it run that way. If they sell a 12-volt adapter, I buy it. Then there's those ones where we got to use those other kits. Then there's ones where you can get these added battery things, little adapters, 12-volt stuff. If you're going to do the off-road capability, off-grid lifestyle, off-grid capability, you're just going to have to become intimately familiar with things that involve rechargeable batteries and DC power. When you don't have a choice in a matter, then you get the AC inverters. And what most people are doing, the decision that most people are doing when they look at all this stuff, I've used printers on inverters. Yeah, the printer will burn out a little quicker, but you know what? It's 59 bucks. So at that stage, I don't care, because 12-volt only units are going to be obscenely expensive. And sometimes when you pop open a box and you look inside, you'll realize that some of these devices actually run on DC anyway. And it just takes some exploring around and playing with it to figure out which devices that works and which ones it doesn't.